This is Hebden problem number 103. A 1.021 gram sample of a weak monoprotic base is dissolved in 100 milliliters of water. We titrate three separate 25 milliliter samples of the base with 0.0523 molar HCl. In trial number 1, it takes 17.98 milliliters of HCl to reach the endpoint. In trial number 2, it takes 17.79 milliliters to reach the endpoint, and in trial number 3, 17.83 milliliters of the hydrochloric acid to reach the endpoint. Anytime you have more than one trial, you need to check and make sure that you don't have any, what's the word we are looking for? We check to see if there is an pause the video and answer for yourself. Outlier. Can you see if there is an outlier? Are any of those three? The first one, yes, indeed. Okay, it's relatively far from the other ones. These are only, oh my God, that's loud. These are only 0.05 milliliters apart. Okay, but that other one is like more than 0.1 milliliters apart. Actually, that's only 0.04. Huh. There we go. Okay, so when we do our calculations, we are going to ignore this data point. What would we do with the other two values? Average, yes. Okay, so we are going to take the average of those two, and we have, so the average volume of 0.05023 molar HCl is 17.79 milliliters plus 17.83 milliliters divided by 2 is 17.79 plus 17.83 equals divided by 2 equals 17.81. I feel like I should have been able to do that in my head, but I couldn't. Okay. So that is our molarity of our HCl. And there is our volume. And because this is a titration, we're going to follow that little 4-box step process. Okay. And I'm going to run out of room here. There we go. So what goes in that first box? First of all, is it the known or the unknown that goes in the first box? Yeah, that's our known. And we start with our given info about the known. And then we convert it into what? Stoic thingy bobs, moles, 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 moles. Yes, okay. So this step, you're always going to convert to moles. Okay. Let's put a big star beside that because step 1, you're always converting into moles, and that's going to be moles of your known. I don't know why I wrote moles at the bottom, but that's okay. Okay. In the second step, we're always going to be converting into what? We have moles of the known. Now we're going to convert into moles of the unknown. Yes. Okay. So again, this is always going to be moles. Star, highlight. Okay. And that will be our unknown. And then finally, we're still working with the unknown. And I usually just put We don't know how to spell unknown. We're just going to put whatever here, because that's going to depend on what's asked for in the question. Okay? So 1, 2, 3 steps for any titration problem. So this is our 3-step titration problem method. Didn't really leave enough room for that title, but that's okay. Okay, what do we always use for step number 2? To go from moles of the known to moles of the unknown. Yeah, the stoich ratio. Okay, so that is the stoich ratio. What is the stoich ratio? Where do we find it? From the equation. Yeah, it's the from coefficients of the balanced equation. Okay, so we are going to actually need a balanced equation here. So let's go and check out what our two things are being reacted. We have HCl is one of our reactants. What is our other reactant? It's an unknown, yeah. That's called that monoprotic base, and I'm not sure I agree with that terminology, but that's okay. A monoprotic base would be one that contains one OH minus ion, or one that produces one OH minus. It's a base that contains or produces one OH ion. Okay, so for example, that could be NaOH, it's got one hydroxide, or you could have NH3, which will accept one proton to become NH4. Okay, so it's either, and if it accepts that proton from water, let me write that out in more detail here. NH3 plus H2O, NH4 plus, and there's the hydroxide that it would produce. Okay, so monoprotic base, it contains one hydroxide. I'm just going to, in this case, because it's an unknown monoprotic base, I'm just going to call it XOH because that makes my life easier. Okay, so we have HCl. Here's our reaction. HCl plus some monoprotic base goes to XCl plus H2O. And the key thing here, you don't even need to know what the products are really. You just need to know that if you have one hydrogen in your HCl, and if you have a monoprotic base, the ratio between the acid and the base is going to be 1:1. So this stoich ratio here for step 2 is going to be a 1:1 ratio. Okay, so let us take our little box step here, okay, and we will actually figure out who is our known and what are we given about it. In this question, who is the known quantity? Who is the known species? The HCl, yeah, okay. And so we know from our calculation that we have 0.05023 molar HCl, and we have the average volume of 17.81 milliliters. Okay, so our known is 0.05023 molar, and 17.81 milliliter of the HCl. From there, we're going to convert it into, step 1 is going to convert it into moles of the known, so that's going to be to moles of HCl. Step number 2 in any of these things is going to be from moles of our known to moles of our unknown. That's going to go to moles of the unknown, which is the monoprotic base. Just call it that. Okay. And then finally, step number 3, what are we being asked for in this question? Oh, and I didn't write it down. So let's just read from the question. Oh, what is the molar mass of the unknown base? So we want to know, sorry, there was a thump in the background. That was exciting. We want to know the molar mass of unknown base. Okay, so we're going to take this up to this step right here, and that's going to be something that is in common between all titration problems. And then finally, this last bit here, that's going to be the part where, you know, I should have done a video lesson on it for you. Okay. All right. So we have, and I will convert it into liters, I think, because I'm finding molar mass at the end. Molar mass is grams per mole, so I won't want it to be in moles. I won't want it to be in millimoles. So I am going to convert this into liters, 0.01781 liters. So we have 0.01781 liters times 0.05023 moles of HCl per liter. Our liters will cancel, and we will have found the moles of HCl, and so step 1 has been completed. Step 2, going from moles of substance A to moles of substance B, that's always going to use the Stoich ratio. Okay, and we figured out that that was a 1:1 ratio. So we want to cancel our moles of HCl and find the moles of NaOH. All right, and that's a 1:1, oh, not NaOH, XOH. Come back, there we go, XOH. Okay, so we plug that in to the calculator, 0.01781 times 0.05023 equals, I'll write it down here, 8.946 times 10 to the negative 4 moles of XOH. Okay, so if this was a question that you were doing on a test, you would get 2 marks out of 3, for example. Now we need to do our last step. We need to find the molar mass of the unknown base. And the key thing about knowing this is knowing the units of molar mass. And the units of molar mass are the grams per mole. And if you know the grams that you have of your unknown base, and if you know the moles of the unknown base, you can divide the two and you will get the molar mass. Okay? So, do we know the grams of the unknown base? Yes, yes, we do. It was given to us at the beginning of the question. It was 1.021 grams of the unknown base. Do we know the moles of the unknown base? Yes, we do. We just calculated it right here. So that is 8.946 times 10 to the negative 4 moles of XOH. And then all you do is you divide. So 1.021 divided by that is 141.3. That seems like a really big number. Did I do something wrong? Let me just check. Okay. Update. Where are you? PDF. Hebden titration. Number 103. Okay. Huh. Oh, did I do something wrong? Oh my God, I did. Okay, hang on. I know exactly why I went wrong. Anyone else know why I went wrong? Something to do with the volume. Yeah, it's absolutely something to do with the volume. I wasn't even thinking. I should have been reading my question more carefully. I traded 25 milliliter portions of this, okay? So this was the moles in 25 milliliters. Okay. So if that was the moles in 25 milliliters, but I dissolved, if you remember from the question, I dissolved my 1.021 gram sample into 100 milliliters. So if I know the moles in 25 milliliters, then I will also know the moles in 100 milliliters. So this right here is incorrect, okay? So the moles of XOH in 100 milliliters is equal to the moles of XOH in 25 milliliters. What should we do with that? We should multiply it by 4, okay? So that's going to be equal to 8.946 times 10 to the negative 4, and then that's going to be times 4. That'll be moles. And so we get 8.946 times 10 to the negative 4 times 4 is 3.578 times 10 to the negative 3 moles in 100 milliliters. Oh, that's looking better. Okay, so molar mass is the grams of XOH, whoops, per the moles of XOH. Why can't I write that? There we go. OH. And so that we dissolved 1.021 grams, and that was in our 100 milliliters. And that was 3.578 times 10 to the negative 3 moles, and that was also in 100 milliliters. Okay, and we get 1.021 divided by 3.578. E3 negative is, that looks better, 285.4. And our unit is grams per mole. Grams per mole. Is good? Alrighty. So just watch out with your volumes there. Obviously, it's easy to make a mistake. If you would like another practice that's very similar to that one, you could try, now that you know how to do it, you could try number 105. Okay,